Lorenzo. This is Burger. And what we're trying to do is we're trying to make an Arduino controlled pellet smoker for ET370, the electronics course here at Cal Maritime. And we are going to have it controlled by a microcontroller. We have these Arduino microcontrollers that we're learning how to program. And the objective of this is to have a pellet smoker that can be controlled by this microcontroller and monitor the temperature of the meats that we're desiring to smoke. And see now what it's going to do, it's going to go...
Hold on. Problem uploading to board. Did you press upload?
I didn't.
Neither did I. No, see, there's something else going on here that we don't quite understand.
It has something to do with the code.
Well, this is the same code that we've used before. I mean, I don't see why.
No, it isn't. We did our own code last time for the auger.
No, I did this.
Function runs over and over again forever.
There's something else going wrong because it's not that, it's the relay.
Oh, the relay's hooked up correctly. And one way we can test it is by just hooking 5 volts up to it.
And it's not turning on at all. It's click, click, click.
Try it now. It's only coming on and off for a few seconds. So let's try to
There's something else going wrong because it's not that, it's the relay. A little bit.
Alright, well, we got it to work.
Yeah.
But according to the Arduino, we're supposed to be using pin 13, but when we use pin 9, it seems to work better, so that works. Okay. So we're going to have a voltage regulator that we can actually use. It kind of acts as a potentiometer for this AC fan, so we can actually adjust the speed gradually. It just won't be full on, full off. We can adjust the voltage output being regulated to the fan, and so that way we can control the amount of incoming air to the pellet smoker, and we can fine-tune the temperature inside the pellet smoker.
Yeah. Spring break, and while most people get to go on some sort of vacation, me and Ryan happen to be here for the entire week, so we used the time to get a lot of work done on our project. We have everything laid out and wired up. What we want to do, and what took the bulk of our time was writing the code for this entire process, and I'm going to show you the lines once we get it pulled up for everything, and then we're going to turn it on, and we're going to show you the process for our automated pellet smoker to work. So our code, and we won't bore you to go through everything, but it's a whole bunch of stuff we had to go through and figure out how to logically get everything to do what we wanted to do on our pellet smoker, which took about a total 8 to 12 hours. We have the auger right here. This is our burn cup, and inside the burn cup we have an igniter. Put that on down. Our convection fan over here. A relay bank here, which is going to control what turns on and what turns off for all of these things. This is our 5-volt power source. And this is a breadboard. Eventually this won't be part of it anymore. We're actually going to high wire everything in. We have these 4 buttons here that are going to help us move from different states, different parts of the process for it to smoke meat automatically. And of course we have our Arduino right here. So the idea is, when we plug it in and start it, you press a button. When you come under this first button, you'll turn on our convection fan. And then you can set the amount of time you want the auger to run for and the time in between when it'll run.
Well, this is our state function diagram, and I don't know if you could really see it, but we had to build this logic diagram in order for us to actually think of how we were going to write our code. And we have 4 different states, actually 5 if you include state 0.
Which is the state we're in right now.
Which is the state that we're in now. So we have these buttons set up, and the buttons are what allow us to change in between states and allow us to control the feed rate and the feed delay of the auger, so we can control how much fuel we're feeding the smoker.
So from right here, you would choose these 2 buttons here, and that's going to decide how long the auger will run for, so deciding how many pellets will feed into the cup, as well as the time delay in between when this will fill up the auger cup. So if you want less smoke, less heat, you would set the delay time to last longer. If you want more fire, more heat, you might make that go a little bit quicker, as well as make the motor run longer to fill up with more pellets. After you've chosen that, you then go into startup mode. So you press this.
So we press the button 0 again, and we'll go into startup mode. And you heard the relay click on, and the relay clicked on to, for one, start feeding the pellets into the burn cup, and for another,
and once that's in there, that's hot
start
right now.
heating up our igniter.
And to stop the igniter, we actually have a flame sensor here. And what happens is once it detects flame, it turns this off, and that's what brings us into our next state. So it's going to be a while, because we don't remember how much we have actually...
It's like a few seconds,
the timing
10
that
seconds.
we programmed it.
There it goes. It's turning. It's just not fastened down yet, so
it's hard to see it turn. It's really slow. You see that light on right there? That means this auger motor is supposed to be spinning. It's not. Maybe I should switch these around.
So we're not. Oh, yeah. Turn it off. The wire came out of the relay. So yeah, checking basics here.
Usually it's something simple.
At this point, we've just entered times into the program that were just random times. Those times aren't correlated with how long it actually takes to fill the burn cup, let's say, or how long it takes for the pellets to burn down to a certain point, to where we need to feed more pellets. So it'll be that kind of, that'll be the next phase. And we have to do some fabrication work in order for us to get to that point.
So this is what we will fill in with pellets, and eventually this auger will go in here and through here into a barbecue to actually feed the pellets into the burn cup to light them on fire. What we have here is a pre-testing working prototype of our pellet feed smoker. We've got all the wiring done, we have coding done that goes through. We've run it through the initial phases to make sure that the state switch, everything turns on, does it for us as long as it's supposed to do, that the flame sensor actually senses a flame and not a flame going out, to turn off the igniter, which turns on, and it works right now. We haven't tested it, we haven't put any pellets in here, we haven't lit anything on fire, but everything turns on, which is really cool.
So some of the problems that we've actually encountered up to this point from the last time that you saw us was, first off, when we first turned on the pellet smoker, we weren't having enough convection air coming through the burn cup. So what we actually had to do was modify the housing that the fan was mounted in, and we also had to modify the burn cup. We had to drill a few holes in the burn cup, and we actually had to plasma cut out the back side of the mounting box for the convection fan. Also, our buttons. We had one hell of a time wiring up our buttons.
I hate these buttons.
We had some wiring issues. I initially wired them up, and I wired up the pull down resistors wrong, and we were having all kinds of issues where the buttons were constantly on the whole time. So once we fixed that and resoldered everything,
it was great.
It tended to work out well.
The last problem that we really had was with our flame sensor. First off, one of the things we're kind of worried about in the first place is having this sensing device inside of a barbecue.
Yeah, we might change that. We probably will change that.
We're going to keep that. But what was happening was the way it was coated in, and we didn't notice it because we were just using a lighter, but it would sense, it wouldn't complete any of its code until it didn't see fire anymore. So we were using a lighter, so when the lighter flicked, when the fire went away, that's when that activated. And that was driving us crazy, so last night...
Burger didn't believe me at first.
I didn't believe him at all.
He didn't believe me that was happening, and then I proved it to him.
I proved it to myself.
And then he proved it to himself.
Yes. And then last night, it actually just took a couple minutes of coding, went through, fixed it. Okay.
Alright, here we go.
Turn it on. Convection fan is going. Close that. Why does it keep going up there?
We should have it in our comments, you know what I mean?
No.
Dead state fan.
That's going to be down here.
Hold on. So, did you put that in? No.
I think you had that in one of them, right?
Yeah.
Yeah, see this motor off, less than 0, motor equals 0?
No, that's what we did, but it's not working.
Why do you have startup auger time equals millis and startup auger time equals millis?
Because Millie's was in there before.
Okay, so I want you to look at this. So when you're in state 2, that is in your set motor delay time. Is that right?
Yep. Yeah.
And then when you push the button again, it's going to go into your ignition.
We want it to, but we want it to feed the pellets
That's
for
right.
a certain amount of time, and
That's
then
right.
the igniter come on. So how would we set
Get
that
rid of
time?
Well, when you're in state 3 now, if millis minus start time is greater than 5,000,
That's where it is.
that's where it is.
Oh,
Right?
okay. Yeah.
So
So
right there, we
that's
want to
what
make that like 45,000.
Come on.
Sneaky, sneaky.
But you don't want it to be 45. I don't know.
I can't mess with your computer. Alright.
Could you just pull out your phone and look that up for me?
I didn't know.
really quickly.
I
And you're
I
just like,
don't know
I'm
what
going to
you're
sit here and
doing."
giggle at you. That's what I'm going to do. Done? Done. Okay.
Turn her on.
We're here at the project fair. The end of the semester is almost here, and I'm ready to get my grade. We have the hopper working. The code is working, and Ryan even spent 15 hours all night last night smoking a brisket, which was ready at about 7:30 this morning. For those of you wondering,
It was kind of a success story at the end because I took on this big chunk of meat that I thought I was never going to be able to cook. And
first it looked like this.
yeah, first it looked like that.
Then the sun came up, and then it
And then
looked like that.
that.
That's what happened.
And that's what happened. And then Burger shows up at like 8 o'clock in the morning. He's
Well,
like,
I mean, to
why
be fair,
didn't you wake me up?
I didn't say that. No.
So when are you going to start making Mark II?
Burger, probably never.
Nope. Nope. I'm good.
It's a relief. I know we put in a lot of work and a lot of dedication into our project, and it's just good to see it come to an end, and
It is good to see it come to an end. Yeah. No, it was good. We finished writing the final report for it last night, and that was a good chance to kind of go back and reflect on the project. Even though there was differences throughout the entire thing, sometimes some heated words were exchanged.
mainly by him.
We can start again. No, it was overall it was good. I'm glad we're done.
Good job, bud.
Thanks.
I'm glad we're finished, and yeah, I'm glad we won. That does feel good. That feels nice.
It does feel nice.
Yeah.
We put in a lot of hard work and
Skip spring break.
skipped a good portion of spring break in order to make it happen. And it was kind of nice to see a project, have an idea, and see it through from, start to finish.
I mean, I don't see myself, but it'll be interesting to see what Ryan does to fix it up in the future.
Yeah.
I'm just gonna watch him.
He's just gonna watch.
I'm just gonna watch. Yeah.